All right, guys, section 5.4, we are looking at the probabilities of disjoint and overlapping events. So the biggest difference that you're going to notice in this homework is the word or. Instead of saying what's the probability of flipping a heads and rolling a 6, we're going to be seeing what's the probability of rolling a 6 or rolling a 2. So the word or is going to be involved, which is going to change the math a little bit. So first thing that we need to understand, the difference between disjoint and overlapping, because that's going to change how we add things together. All right, so what it means for something to be disjoint. If I were to say, what's the probability, and we're going to just stick with a simple, basic example here. What's the probability of rolling a 2 or a 3? Okay. If I were to roll a dice, there's no way that I can get a 2 and a 3 at the same time. Okay, that makes this a disjoint event because both things can't happen at the same time. But if I were to say, what's the probability of getting a 2 or an even number, these can happen at the same time. Because I could get a 2 and the even numbers are 2, 4, and 6. So 2 shows up in both lists. So that makes this an overlapping event because 2 shows up in both of them. Now, the formulas that you're going to use are a little bit different. If your events overlap, so there's 2 formulas that you're going to want to write down. Overlap is this first formula. You take the probability of A or B happening. That's equal to the probability of A plus the probability of B minus the probability of both of those things happening. If it's a disjoint event, meaning they both can't happen at the same time, then you're going to use this second formula, which just makes you add the probabilities together. There's nothing to subtract because nothing overlaps and gets counted twice. Okay, so let's show you what that looks like. The examples make it a lot easier to see what's happening here. So a card is selected from a standard deck of 52 cards. What is the probability that that card is a 10 or a face card? All right, so the keyword, first of all, is or. That means I'm going to be adding probabilities together instead of multiplying. So probability of a 10 is the first event, or the first part of it, or the probability of a face card is the second option. All right, so how many 10s are there in a deck of cards? There's 4 10s out of 52 cards, plus the probability of getting a face card. Remember, those are jacks, queens, and kings, and there's 12 of those out of 52 cards. Now, here's where I needed to think for just a second. Are any of the cards face cards and 10 cards? Well, no, because the faces are jacks, queens, and kings, not 10s. So I don't have to subtract anything. All I have to do is add this together. I get 16 over 52, which should simplify to be 4 over 13. All right, so my probability of getting a 10 or a face is 4 out of 13. Now, example 2, I'm going to pick a card again, but this time, what's the probability that I get a face card or that I get a spade? Okay, or means I'm going to add again. The probability of getting a face card, well, there's 12 face cards out of 52 total cards, right? Jack, queen, and king. And the probability of getting a spade, well, there's 13 spades out of 52 cards. But this one I've got to be careful about because some of them are face cards and they are spades. They fit both categories. There's the jack of spades, there's the queen of spades, and there's the king of spades. So those 3 cards are counted twice. So I have to subtract those 3 cards. So I'm going to minus 3 out of 52. All right, so 12 plus 13 is 25, minus 3 is 22 out of 52, which is 11 out of 26. So the probability of getting a face or a spade is 11 out of 26. I had to subtract these ones because I counted them twice, all right? So let's do one more example of each before you try to do this on your own, okay? What is the probability of selecting an ace, or I'm doing this problem right here, the probability of selecting an ace or an 8? Okay, well, or means add. So what's the probability of getting an ace? And what's the probability of getting an 8? Well, the probability of getting an ace, there's 4 aces out of 52 cards. The probability of getting an 8, there's 4 8s out of 52 cards. And the or means I need to add those together. Now, before I do, I just need to double check. Are there any cards that are aces and the number 8? And the answer is no. Nothing can be an ace and an 8. So I add these together, I get 8 out of 52, which simplifies to be, what, 2 out of 13? So I have 2 out of 13 chances of picking an ace or an 8, all right? Well, now let's select the probability of selecting a 10 or a diamond, all right? Well, the probability with an or means I'm going to add. So what's the probability of getting a 10? Well, there's 4 10s out of 52 cards. What's the probability of getting a diamond? Well, there's 13 diamonds out of 52 cards. So those I'm going to add together, but I need to double check. Do any of these overlap? Are there any diamonds that are also 10s? And the answer is yes. There's one of them. There's the 10 of diamonds, right? So I've got a minus 1 out of 52 since it showed up in both categories. So 4 plus 13 is 17, minus 1 is 16 out of 52, which I think we did earlier already, right? Doesn't that end up being 4 out of 13? So the probability of getting a 10 or a diamond is 4 out of 13, all right? Okay, homework. 5.4, go ahead, stop the video, and I want you to do 3 through 10 and 13 and 14. So there's what, 9 questions right there to practice what we just did. When you're done, move on to the next video.